नमस्कार दोस्तों, welcome to my channel VNP Networking Tutorials. In today's lecture, we will analyze a Wireshark capture between two routers and understand how a BGP neighbor relationship is formed. Now, these captures were taken when we performed iBGP lab in one of our last lecture. So, here we will focus on three important stages. First is TCP three-way handshake. Second, BGP open message exchange. Third, NLRI advertisement inside update message. The two routers in this example are R1 and it's having the IP 10.1.1.1 and R2. The IP is 10.1.1.2. Okay, so let's look here. If you just look at the sequence number 53, you will see that the source IP is, this is the source tab, source column, this is the destination column, and we are using a filter TCP. Okay, very important. So sequence number 53, you will see that the source IP is 10.1.1.1. that belongs to R1 and the destination IP is R2 10.1.1.2 and the protocol is TCP. Okay, if we go further in the packet details, you will see that look at this specific row. You will see that the source IP is 10.1.1.1, the destination IP is 10.1.1.2. This is the internet protocol v4 IPs, IPv4 IPs. Okay, and just below that line you will see TCP control, transmission control protocol, the TCP packet. The source for this communication was 24767. This is the source port number and the destination port number is well known, BGP 179. You see this. Okay, so the connection was initiated from 10.1.1.1. I can mention it towards the 10.1.1.2. And what were the source port number? The source port number was 24767. The destination port was BGP 179. Okay, this was our first packet. And if you see further in the TCP, the flag you can see here is SYN packet. You see a SYN packet. Okay. And you can also check the same here in this row. Sequence number 53. You can see the SYN packet. The sequence number is 0. Very important. This is the SYN packet with sequence number 0. Okay. Now let's look at the sequence number 54, the next packet. You will see that the source is now 10.1.1.2, which is the R2, and the destination is 10.1.1.1, which is the R1. It's a TCP packet, and you will see that it contains SYN plus ACK. Okay, now the acknowledgement is 1. We know that in the sequence number 53, the SYN packet was having a value 0. Now this is a SYN packet. Okay, so the acknowledgement is always the SYN number plus 1. So 0 plus 1 is 1 and it is sending its own sequence number 0. Okay, you can also see here the details. Now since it's a response packet, the source port is TCP 179 and the destination port is 24767, which was the original source port when the SYN packet was sent from R1 towards the R2. Now this is the SYN packet in the reverse way. For example, you have R1, you have R2. Okay, this was the original SYN packet where the sequence number was 0. Now you have received SYN plus ACK. So what is the value of ACK? 1 because it is a response to the original send packet, but it has its own sequence number. Okay, you can also see the original port number was, original source port was 24767. When there is a response from R2, you see that the source port is TCP 179. You see this? This is the response packet. This is the destination port now. And the flags, the TCP flags, you can see here. These are the TCP flags. Okay, and you will see that the TCP SYN packet is sent with acknowledge. You see this acknowledge, there is one, right? Okay. Okay, if you look at the next packet, sequence number 55, we already checked 53, we already checked 54. Now this is packet number, sequence number 55. The source is R1 10.1.1.1. The destination is 10.1.1.2. Now this is a three-way handshake completing package. Now you can see the sequence number is, and the acknowledge number is 1. So we have the TCP three-way handshake completed here. Three-way handshake completed here. Okay, and you can see that the source port is 24767. The destination port is TCP 179, and this is the acknowledgement packet. You can see this acknowledgement packet set here. So we have SYN packet, we have SYN-ACK, SYN plus ACK, and we have ACK packet. This was between R1 and R2. So here the TCP three-way handshake is completed. We applied the filter as the TCP in the Wireshark, and we captured these three packets. We captured these three packets, 53, 54 and 55. These three packets, they provide the complete three-way handshake. Okay, these provide the complete three-way handshake. Okay, now we have put a filter as a BGP. You can see the filter BGP. And now we are trying to analyze the BGP packets. So if you look at this sequence number 56, you will see that the source is 10.1.1.1 and the destination is 10.1.1.2. Okay, you can verify same here also. The source is 10.1.1.1, the destination is 10.1.1.2. So we have R1, we have R2. R1 is 10.1.1.1, R2 is 10.1.1.2. So the connection has been initiated from R1 to R2. Okay, because you can see that the source port is a random port. What is the source port here is 24767. And what is the destination port? It is 179. So we can say that R1 is initiating the connection towards the R2. Okay, so you can say that R1 is the client and R2 is a server. Here R1 is initiating connection towards the R2 over TCP port 179. After that, you can also focus on this area. You see this border gateway protocol, and what is the message type? Message type is a open message. Okay, so what information we have in the open message? First is V4 BGP. We have BGP version 4. My AS number means R1 is saying that my AS number is 10. My BGP version is 4. My hold down timer is 180. 180 is my hold down timer, ST. Hold down timer is 180. What is my identifier? You can see this. My identifier is 1.1.1.1. Okay. So this information will be exchanged to or will be shared with R2. Okay. So BGP configured on R1 says that my AS number is 10, my hold down timer is 180, my BGP identifier is 1.1.1.1 and my BGP version is 4. So this information is carried out in open message. Please note, very important. Open message carries this all information. Okay, now let's focus on the next packet. The next packet shows that the source is 10.1.1.2, the destination is 10.1.1.1. Means you have R1, it is connected to R2, R1 is having IP 10.1.1.1, R2 is having the IP 10.1.1.2. Now this is the second packet. It is the second packet coming from R2. You can see the source port. What is the source port? 179. What is the destination port? Destination port is 24767. Okay. So this is the second message. And what is the message type? The message type is open. Okay, because it is coming from 10.1.1.2 going towards the 10.1.1.1. And what are the information in the BGP open messages? You can see here. It says that for R2, it's for R2. It shows that my BGP version is 4. My AS number is also 10. Okay, AS number is also 10. And my identifier is 2.2.2.2. So here it says that my identifier is 2.2.2. And for 1, it was 1.1.1.1. For R1, the AS number was 10. For R2, the AS number is 10. So what we are forming? We are forming here iBGP because both AS number are same here. So next thing that the next type of message in the BGP is update message. If you look at this message, update message, what does it contain? It contains very important information which we call as NLRI. NLRI means network layer reachability information. And what information does it contains? It shows that what prefix you are advertising via BGP. You know that we advertise the loopback IP in our lab using the network command and the subnet mask. We advertise, what we advertise in BGP? We use the command network 2.2.2.2 mask and subnet mask. We advertise like that in BGP. Okay, so this information, if you look at this update message, it contains the information what BGP information you are exchanging. Now it is coming from which router? R2 towards the R1. Okay, now if you look at one more message, BGP update message, it's coming from R1 going to R2. And what we have to check this update message here? Very important, network layer reachability information. What does it shows? It shows that prefix 1.1.1.1 was advertised from R1 to R2. We have loopback like this and you have a iBGP form between R1 and R2. So this information, it is carried via the BGP update message. Very important. BGP share the network information to each other using the update message. So thank you for your time and see you in the next lecture.